Good morning and welcome to a terrific Math Tuesday, everyone. We are going to be working on questions like this one, adding and subtracting fractions. So let's take a look. I want to show you a few methods, okay? I'm going to show you an easy way to do it. I'm going to show you a way that uses factor trees. And I'm going to show you a way that's just like for people like, I just see it. I just see like, I know how to do it. Just let me do it in my quick way, okay? If you have three different ways to climb a mountain, you're a better mountain climber than someone that has one way to climb a mountain. That person who has one way to climb a mountain, they get into an obstacle and their method doesn't work. The person who has three ways can sometimes get around that. Annie?
If you have a bigger number, then can you cross-reduce when you're adding and subtracting?
A bigger number and cross reduce?
You know how you can cross-reduce when you're multiplying fractions?
Cross multiply?
No, cross-reduce.
I don't know what that means.
You've never cross-reduced?
I don't know what that means.
It's like you go how many groups of 5 fit into 9?
Oh, is that what we looked at a couple days ago, the quotient method for dividing?
I don't know.
Okay. Anyway, you might find your method in here. Maybe you have a new method that we could add to the list. I'd love to learn it. First step has always got to be create a common denominator. Okay. Now, if we take a look at the anatomy of these fractions here, a fraction has two parts, a numerator and a denominator. The way I remember which one is which is the denominator is the number on the bottom, because demons, we usually imagine demons as something that's subterranean. Okay, so the denominator sounds a little bit like a demon to me. That's how I remember it. You can remember it your own way. So numerator, denominator. We need a common denominator. We need these two numbers to be the same when we're adding or subtracting fractions. Did we need a common denominator when we multiplied or divided? No, we just top times top over bottom times bottom when we multiply. It's much more straightforward to multiply fractions than it is to add and subtract them. Javai?
6 or 3 as a common denominator?
Well, 3 is a common factor here, and we're going to see that that's important as well.
36.
So yeah, this is the I just see it method, and that's great. But let me show you the easy way first. So my easy way is the first thing that I'm going to do with any of these types of questions, I'm going to copy it down again. So let's do that. I'm going to start by copying this question, 5 over 12 plus 4 over 9. And then the easy way to find the common denominator, to create a common denominator, is I'm going to multiply this one, top and bottom, by this number. I'm just going to multiply 9 by 9 on this side, and then on this side I'm going to multiply 12 times 12. Some of you are squirming. Some of you are saying, you don't need to do that, Mr. Jennings. Well, yeah, that's true. I don't have to do it this way, but it will work. And it's easier because I don't have to have any finesse. So now I've got a multiplying fractions question. The reason I'm allowed to multiply these by 9 over 9 or 12 over 12 is because I'm multiplying them by 1, and multiplying by 1 doesn't change what the thing is. It stays the same. So 9 times 5 is equal to 45 on the top. I just do top times top over bottom times bottom. 9 times 12 is 108. 45 108ths plus 4 times 12 is 48 over 9 times 12 is 108. This is very useful if you can't see the common denominator right away. This is one of the possible common denominators. Okay, so now I have found the common denominator, and now I just add the tops up and then I reduce it. So let's go. 45 plus 48 over 108 plus 108. Sorry, 108. So now I do 45 plus 48 over 108. Because I have the same thing on the bottom, that just becomes the bottom of the whole fraction. If I'm adding 1/3 to 1/3, I will have 2/3. It does not change the number that's on the bottom. If I'm adding 3/7 to 2/7, I will get 5/7. They'll all still be sevenths, but now I'll have 5 of them. Here, it's harder to imagine 108ths, but it's the same principle. So now 45 plus 48 gives me, that will be 93. 93 over 108. And now I need to reduce this fraction. So one of the benefits of this method is you'll get more practice reducing fractions. You'll always end up with an unreduced, almost always end up with an unreduced fraction here. So when I'm checking for reducing fractions, I could use factor trees, or I can just spot the common factor to these numbers. And here I can spot, are these numbers divisible by 2? No. Are they divisible by 3? Yes, they are divisible by 3. So I see that 93 is divisible by 3 because 9 plus 3 is 12. 12 is divisible by 3. And 1 plus 8 is 9, and that's divisible by 3. So I can divide 93 by 3, and my calculator tells me that's 31. And I can divide 108 by 3, and that's 36. Oh, someone mentioned this number a little while ago. Oh, there's that number showing up. So we still get there. Now, another method would be to use a factor tree to do this one. Oops, let me zoom out. If I want to find a common denominator faster, I can use factor trees with 12 and 9. So let's go ahead and do that. In this case, I'm going to take the number 12, and I'm going to see that 12 is 3 times 2 times 2. I would say 3 times 4, and then 4 is 2 times 2. So there's the prime factors of 12. 3 times 2 squared. And then 9 is 3 times 3. It's just 3 squared. Okay? And then I count the factors. And I see this one has 2 factors 2 and 1 factor 3. This one has 2 factors 3 and no factors 2. So what I need to do is increase the number of factors 2 here by 2. So I'm going to need to multiply this one by 4. And I'm going to need to multiply this one by 3. If I do that, if I multiply 12 by 3, I will get 36. If I multiply 9 by 4, I will get 36. And all I'm doing is using this method of factor trees to just see what number connects these two. So this is one way that if you can't see it right away, you can use a factor tree to see what factors are missing on one side and on the other side. So now we've seen it. So now we can use this method. I just see it method. So now I start again in the same way. I write down the problem, 5 over 12 plus 4 over 9. And now I know that I need to multiply my 12 by another 3 because there's only one factor 3 in that number and there's 2 factors 3 in the 9. So I can multiply this top and bottom by 3. And then in this one, the 9, it needs to be multiplied top and bottom by 4 because it doesn't have any factors 2. So when I multiply this top and bottom by 4, that will create a common denominator here and here. 3 times 12 is the same thing as 9 times 4 because they all will now have the same factors that build those numbers. So I bring down an equal sign because the thing I'm going to write next is the same as what is on this line. And I do 3 times 5 is 15 over 36, because 3 times 12 is 36, plus 4 times 4 is 16 over 36. Another thing I want to do is check in with my numbers at this point and make an observation. Oh, 5 over 12 is ever so slightly smaller than 4 over 9. Isn't that interesting? It's only 1/36 smaller. Cool. Okay. And then maybe you don't think it's cool, but I think it's cool. So this is equal to 31 over 36. Again, I write these. Oh, I'm skipping steps. Don't skip so many steps, Mr. Jennings. I write the whole thing over the same denominator. I have 15 plus 16, and that's equal to 31 over 36. And that's our method. There's 4 different ways that we can do it. Notice with the factor tree method, I'm going to use factor trees just to spot this thing and then go through this method here. By multiplying by bigger factors over there, this method is just the go ahead, crunch it, and then reduce it later method. So we just ended up with an extra factor 3 by multiplying 9 by 9 over here and 12 by 12 over there. It only created an extra factor 3, that was all. Okay, so now let's take a look at it with a subtraction question. Subtraction of fractions is pretty well the same thing as addition of fractions. We're just going to have a negative sign in there that's going to follow us through our calculations. The creating of common denominators works exactly the same way. So let's take a look. I missed some stuff, yeah, but that'll be fine. 3 over 4 minus 7 over 10. First of all, start with a prediction. Imagine these two numbers and say, about what does that look like? Like, what is that going to be? I can actually do this in my head without using any fractions by knowing that this is 3/4, that's 75 cents, and this is 7 dimes. A tenth of a dollar is a dime. So 3/4 minus 7 dimes, that would leave me 5 cents. 5 cents is a nickel, or 1/20th of a dollar. So I know that this will give me a positive answer. 3/4 is a little bit bigger than 7 dimes, and that the answer will be 1 over 20. Okay. Now let's try the easy way first. First thing I do, always copy down the question carefully. Next thing, I can multiply both of these by 1. I'm going to multiply this one by 10 over 10 because I don't see it yet. And then I'm going to multiply this one by 4 over 4. Where did those numbers come from? Down here. Okay, I want to have 10 times 4 and then 10 times 4 over here. See how that will create? This is like the brute force method of create a common denominator. Always works. Just this will probably give me back 2/40ths instead of 1/20th. Fine. So let's go. And I can see that here because this is going to give me 30 and this is going to give me 28. Cool. Now, I put an equal sign. This means the next thing I'm going to write is equal to what's above. So 10 times 3 is 30 over 10 times 4 is 40 minus 7 times 4 is 28 over 10 times 4 is 40. Hooray, common denominator. Notice that the minus just follows me down. That's the only difference between add and subtract here. Now I put them all over the same denominator, and I have 30 minus 28, because if I have 30 of something and then I take away 28 of something, I will have 2 of something left. And now this gives me 2 over 40, and 2 over 40 happens to be 1/20th. Hold your applause. That's a little bit like telling the sun to rise in the morning. Of course it's going to do that. Okay. Oh, you have a question? No? Okay, cool. Now, could we have used factor trees here? Absolutely. Let's take a look at what factor trees would have looked like. We would have done a factor tree for 4 and found that's 2 and 2. We would have done a factor tree for 10 and found that's 2 and 5. So we would have looked at this and we would have said, we need to add a factor 5 here. We need an extra factor 5 for this one, and we need an extra factor 2 over here. And that allows us to just see that 10 times 2 is 20 and 4 times 5 is 20. 20 is the more efficient common denominator you could use here. And maybe you just see it. So if you just see it, just jump to this level right away. So here, again, same steps. I write down the question carefully. I multiply top and bottom by the same thing. Oops. I think I have an undo button. Yay. I multiply here top and bottom by 5 because the missing factor there was 5. This is 2 times 2. This is 2 times 5. This needs a factor 5. This needs an extra factor 2. It already has one factor 2, but it needs another one. So I'm going to multiply that there and multiply that there. I use an equal sign, which is a promise to my reader that the next thing I write will be the same. 5 times 3 is 15. 5 times 4 is 20. Minus 7 times 2 is 14. Over 10 times 2 is 20. And then I put it all over a common denominator and do the subtraction. 15 of something minus 14 of something over 20 gives me 1/20th. There's my nickel. Because I start with prediction, and I try to just guess, like, is this going to be bigger than 1, smaller than 1? Is it going to give me a negative number back? Is it going to give me a number bigger than half? My mind is actively engaged with the question all the way through. That means that when I get to the end, I get a light bulb that's not quite like figuring out who the murderer is before the TV show reveals it to you, but it's the same principle. Then I get a little bit of pleasure, a little bit of serotonin, dopamine release in my brain that says, you just had fun doing some math. And that's the more important lesson than adding and subtracting fractions. That's a way that you can start to enjoy the 194 school days of the year. That's a way that you can start to engage the mind a little bit more with your math practice. And that way your time is producing more benefit for you. So this is adding and subtracting fractions, everyone. Yay! And any questions, absolutely hit me up by email or ask me during class.